Hi and welcome to this video on how to calculate the weight of reinforcing for any construction project requiring reinforcing. So let's begin. Let's imagine you work for either the following: a reinforcing supplier, a main contractor, a residential builder, or you are just interested in learning how to work out the reinforcing weights required for a project. You have just been handed a set of construction plans, and one of the tasks is to ascertain how much reinforcing is required for the project. How do we work out the total weight required, for which you can then either provide pricing or seek pricing? Where do we start? For this exercise, and to make learning easier, we will work out the total weight of reinforcing required for the foundation, designated as SF2. Once we have completed this process, you can then apply the same principles to obtain the total weight of reinforcing for any project. So, let us begin. In front of you, you can see two screenshots from a set of construction drawings, these being, on the left, a foundation schedule in which we can identify SF2 as a 600 wide by 600 deep foundation beam. And on the right is a cross-section through the SF2 beam, clearly identifying it as a 600 wide by 600 deep foundation beam. For the purposes of this exercise and to simplify our learning, we will ignore the meaning of the letters H and HR as highlighted. We will also ignore the reinforcing bends highlighted in yellow. From the cross-section shown, we will now identify the reinforcing specific to the SF2 foundation. These are the stirrups at 200 centres, which are shown here in red, the links also at 200 centres, which are shown here in yellow, and the H20 bars, 3 at the top and 3 at the bottom, running the entire length of the SF2 foundation beam. Our next task is to work out the lengths of the stirrups and links, remembering we are not going to include for the bends as noted earlier. To calculate the stirrup length, we ask ourselves, what do we know from the cross-section? Firstly, we know that the foundation measures 600 by 600 millimeters. Secondly, we know that it shows the stirrups to have 50 mm cover to the edge of concrete on all sides. So, can you now work out the stirrup length? Okay, if the sides of the foundation measure 600 millimeters and the cover is 50 millimeters on either side, we simply deduct 100 millimeters from 600 millimeters, leaving us with 500 millimeters. Then, if one side measures 500 millimeters, then times this by 4 to give us 2000 millimeters or 2 meters. Based on the explanation just given, can you now work out the length of the link? Yes, you've got it. This measures 500 millimeters, as there is only one dimension to measure. Before we move on to the next slide, please note the following. Number 1, we know the length of one stirrup measures 2000 millimeters or 2 meters. Number 2, we know the length of each link measures 500 millimeters. Number 3, the H20 reinforcing shown at the top and bottom of the foundation runs the entire length of the foundation. Number 4, the stirrups are found at 200 mm centres along the foundation. Number 5, the links are found at 200 mm centres along the foundation. Now we need to work out the length of the SF2 foundation. To recap, the SF2 foundation we want to measure is this. We could use a scale ruler based on the drawing scale to measure it. If we didn't have a scale ruler, we could use the known measurements as shown. Have a look at my workings to see how I worked out the SF2 foundation length 4665 millimeters or 4.67 meters to 2 decimal places. Now we know the length of the foundation, we can now work out the total length for the stirrups, links and bars. Let's work out the total length of the H20 bars first, as this is the simplest. We know there are 6 H20 bars running the entire length of the foundation. Thus, 6 times 4.67 meters equals 28.02 meters. In the case of the stirrups and links, we know that they occur at 200 mm centres along the entire length of the foundation. So, we need to know how many in total there are in the foundation. Quite simply, we divide the length of the foundation, 4.67 meters, by 0.2 millimeters, equaling 23 number, rounded to the nearest number. Then, for the stirrups, we simply multiply 23 by the length of each stirrup, which was 2 meters, giving us a total length of 46 meters. And for the links, we simply multiply 23 by the length, which was 500 millimeters, giving us a total length of 11.5 meters. It's quite a lot to take in if you've never measured reinforcing before. So please stop the video now to review, go for a drink or some food, and then press play to carry on and continue when ready. The next piece of the puzzle is to understand what the numbers mean next to the letters H and HR, that is H20 and HR10. Well, these numbers tell us what the diameter of the reinforcing is. For this foundation, the reinforcing bars are 20 mm and both the stirrups and links are 10 mm. And for the final piece of the puzzle, we need to know what is the mass of the reinforcing, i.e. kilograms per meter. In our specific case, we have 10 mm and 20 mm reinforcing. Thus, the mass for 10 mm diameter reinforcing is 0.617 kilograms per meter, and for the 20 mm diameter Rio, it is 2.466 kilograms per meter. Now we have all the information to work out the total weight of reinforcing in the foundation SF2. Let's work it out. In front of you is a summary table of all the information we have gathered to be able to work out the total amount of reinforcing in foundation SF2. For example, for the HR10 stirrups, we worked out that there was 23 number required along the entire length of the foundation. We then calculated the length of each stirrup. We then multiplied the number by the length of each stirrup to give us a total length. Next, we then took the total length, i.e. 46 meters, and multiplied it by the appropriate kilograms per meter, in this example 0.617, to give us a total kilogram of 28.38. By carrying out the same process for each reinforcing type, we arrive at a total weight of 104.57 kilograms. And that, my friends, is how we calculate the weight of reinforcing. Thanks for watching this video. I hope you have learned something from this that helps you either in your studies or in your day-to-day work. If you have learned something from this video, please give me a thumbs up. It would really be appreciated. Bye for now.